Morning, everyone. Today I'm going to talk about demystifying the Arcane of lateral movement between Azure and on-premise AD. So I'm Echo. I work as a cybersecurity researcher at Cycraft, and this research was done together with my colleague Jimmy. Fortunately, he's not here because he can't drink. So here's today's agenda. We'll talk about what's Azure hybrid identity to make sure everyone is on the same page, and talk about attacking from on-premises to Azure, and then the opposite side, attacking from Azure back to on-premises. Then some takeaway for you guys. So, what exactly is Azure? Azure is a Microsoft computing product containing service about identity, computing, storage, and etc. And HID, formerly called as Azure AD, is a Microsoft cloud-based IAM service. And you can think it as the core of whole Azure. So something worth notice is that when we talk about Azure, we mean a whole bunch of things generally. But when we talk about a specific Azure resource or Azure roles, we mean something below here. So what's Azure hybrid identity? So what makes Azure different from other cloud service providers is that it allows users to sign to Entra ID with their on-premises identity without creating a new one. And it relies on the hybrid identity authentication methods, password hash synchronization, pass-through authentication, and federation. And for the first two of them, they rely on the Entra ID Connect agent to connect or communicate with Active Directory and Entra ID. And for federation, this role was replaced by ADFS. And not only our users need to have identity, but device also needs an identity. Just like your device could be managed by your domain, we will say that the device was domain. So cloud device joins. There are three types of device join. The first one is Entra register, which means you log on to your device with your local or domain join account, but you log on to your Office application with your Office 365 account, which is actually Entra ID account. And another one, just like you can join your domain, you can also join your Entra ID. So another one is Entra ID join. And the last one is you can not only join your domain or Entra ID, you can join both of them, and that is hybrid join. And this required hybrid identity authentication to be set up. So the 101, boring 101 has been over. Let's talk about attacking from on-premises to Azure, abusing hybrid authentication methods. So the detail of password hash synchronization works like this. First, the Entra ID Connect replicate the user's password hash and store it in a SQL database. Then it hash it again and sync it to Entra ID. So when a user tries to log in, it authenticates to Entra ID, and Entra ID will validate the authentication. And what's the security issue with the password hash synchronization? When we look into the permission details, Entra ID Connect automatically create an account start with MSOL, and it has the DC sync privilege to replicate the user's credential, and it also creates another account start with sync. This account has the role directory synchronization account, which also is a high privilege role in Azure to sync the user into the cloud. So once the Entra ID Connect was compromised, the attacker have the ability to dump those two accounts' plain password, which will somehow gain the attackers high privilege in both cloud and on-premises. So let's talk about pass-through authentication. So pass-through authentication works like this. The user tries to authenticate and through Entra ID, and Entra ID pass through the authentication to Entra ID Connect, then pass through the domain controller. Domain controller validates the authentication, then returns back the result. So what's the security issue for pass-through authentication? So it relies on the trust relationship with Entra ID and Entra ID Connect, and Entra ID Connect with domain controller. So once the Entra ID Connect was somehow compromised, the attacker will be able to pass the function log on user W. So whenever the user tries to log in, the Entra ID, the attacker may get the plain password that user tries to type in. And similar security issue happen in federation, since it also relies on the trust relationship between Entra ID ADFS and domain controller, and this attack is called Golden Samuel. So general detection and mitigation for these attacks, call logs will only show signs of anonymous login IPs and user agent, but these attacks are really hard to detect. And it relies more on host forcing technique for detection. But in a mitigation way, treat ADFS and Entra ID Connect server as your tier 0 assets. They are almost important as your domain controller. And ensure you deploy EDR tools installed on these servers. So for red teamers app stack, compromising ADFS and Entra ID could be nearly as difficult as compromising domain controller in a well-protected domain. And the question pop up, is there any easier way to remove them from on-premises to Azure without compromising ADFS and Entra ID Connect? And of course, the answer is yes. Let's talk about stealing access token. So Entra ID implements the OAuth 2.0 and OIDC standard as the foundation for its authentication and authorization. So it basically looks like this. The client application initiate an authentication request with the scope and resource it needs. The Entra ID return back the access token and refresh token. Then the client application send a request to the API endpoint, or so-called resource server, with an access token. And the resource server returns back its response. However, access token only have a lifetime about an hour. So it needs another token that is refresh token to it's used for. And you can use a refresh token which have a lifetime of 90 days to return for a new access token if the old one is expired. And ways of treating OAuth token. When I mean say about OAuth token, I mean not only access token, but also refresh token and primary refresh token we will talk about later. There are 4 ways to attack to steal them. Phishing, stealing local device, and CI/CD pipeline, and from metadata service. But the last 2 of them are only cloud issues. We are not talking about that. So we'll just talk about phishing and stealing from local device. So phishing for access token. Type of phishing contains device code phishing, which basically how you log onto your necklace with a QR code on your smartphone. Illicit consent grant phishing works like this. The user tries to use some kind of client application, and the client application needs some scope or resources to work properly. So the Entra ID asks the user if you want to consent those permissions. So something like this pop up, and it will show the permission it needs. And if the user clicks on the accept button, the Entra ID will return the access token and refresh token to the client application. Then the client application, if it is malicious, it can gain access to your resource. And of course, we have some AITM phishing, which hides its true nature of device code phishing or illicit consent granting phishing, or maybe password phishing. Yeah. Then let's talk about stealing access token from device. The easiest one is abuse the Azure management tool containing AZCLI or AZ PowerShell. So it actually have a command, get AZ access token, that returns you the access token. And by default, it returns you the access token of Azure resources. But you could specify the resource you want the access token. So like the picture shows, you can specify you want a Microsoft Graph access token, which will make you have the ability to manipulate Entra ID. And another issue is for files. In last year's CVE, it turns out that AZCLI store your local credentials in logs in plain texts. So attacker can just see it, your plain text credential in Azure CLI's log. And another issue is a hardcode credential in your script or code. I mean, these attacks are targeted at specific endpoint, maybe cloud engineers, device, or some special hybrid servers. So we're seeking for, is there any more general attack techniques that we can attack everyone? So, do you guys not have an Office 365? So of course, everyone use it. So dump the memory of, there's a very sexy attack dumping the memory of Office applications. You can use something called a token finder and to dump your PowerPoint or WinWord. And it turns out you can get an access token with an Outlook permission. Not only that, you can also dump an access token with a Microsoft Graph permission. And in that, we can see we have a scope called group rewrite all. And with this scope, if the user has the ability, we can add ourselves into any Entra ID group in the tenant. So let's talk about stealing primary refresh token. Before we talk about what's primary refresh token, we have to talk about what's single sign-on. Single sign-on is an authentication method that enables users to secure authenticate with multiple applications using just one set of credentials. So you can just authenticate once and get access to all resources. And it works with password hash synchronization and password authentication in a hybrid joint domain. In Azure, this is typically done using something called primary refresh token to present an access token and refresh token. So now we know that primary refresh token is a fundamental in Entra ID's single sign-on. So it could authenticate to all applications. You could use a primary refresh token to refresh for any refresh token and access token. And it contains an MFA claim, means if an attacker obtains it, it could conduct some kind of MFA bypass. And it also contains a device ID which tied to the device. Something worth notice is generally you can use a primary refresh token to return for a refresh token and access token, but you can't use an access token or refresh token to request for a primary refresh token, generally. So generating a PRT cookie. Since primary refresh token is so important, Microsoft updated several times to make it more secure. Mimikatz has no longer to retrieve PRT in the device with TPM. And another significant issue is that PRT cannot directly request for a refresh token and access token anymore. You have to get some nouns and generate a PRT and a nouns to generate something called a PRT cookie. So the generate flow looks like this. Browser initiates a single sign-on session to obtain the nouns, and then the browser sends a nouns to the browser extension called browser core. And the browser core will handle all the technical things for it, like communicating with LSAS. And the browser only needs to read the std out of the browser core, which it will get the PRT cookie, and use that PRT cookie to get return for the access token and refresh token for any resources. So how do we steal primary refresh token from local device? You can use a tool called root token, which it will mimicate how browser interact with the browser core to get the primary refresh token cookie. So let's say goodbye to Mimikatz. We don't need to get the real PRT. We can just mimicate how browser interact to get the PRT cookie and do what we want to do. So since the PRT was sent as an HTTP cookie, of course you can fish with some kind of AITM tools such as EvilJinx to get the primary refresh token cookie. Another more interesting attack is that we can not only fish for a primary refresh token cookie, we can also get it from another way. So the procedure of token flow during Windows device registration setup looks like this. First, you try to join your device into Entra ID. You actually sign to a specific application called Microsoft Authentication Broker, and it obtains access token and refresh token. And then the user uses the access token to join the device and get a device identity. Then your OS system will use your refresh token and the device identity to request for a primary refresh token, which is a violate of the token security architecture. So it means that we don't need to fish for the PRT cookie. We can get the refresh token of Microsoft Authentication Broker, then request for a real PRT cookie. So Since that Microsoft Authentication Broker also supports device code login, you can use Lateral to obtain the device code phishing. And mitigation for stealing the OS token. So you can set up some conditional access policy or token protection that while the token protection is bound to a device and its appearance in other places, it will revoke the token. Or you can revoke the refresh token manually if you find something suspicious in your tenant. So let's talk about attacking from Azure to on-premises. So imagine the consequence of ignoring the attack service. Well, you are eating your breakfast with your coffee, and you found out that all your computer's device started executing some malicious script. And I think there will be a nightmare for all of us. So executing this kind of attack may need some prerequisites. You need to enable specific hybrid solutions, and the attacker usually needs to obtain a high privilege role in Entra ID or have permission to a specific Azure roles. And this means that attacker may have to do some privilege escalation first, but there's an exception that attacker could obtain a high privilege role directly by insecure synchronization. So this is what a secure synchronization setting should be. You can see your on-premise account and your Entra ID account, and in the middle, you see the sync account. Your privilege account in Azure should be a cloud-only account. And if you grant the sync account with Azure's high privilege, once their access token was stolen from the device, the attacker can get a high privilege access token, and they don't need to do the privilege escalation anymore. So our threat model looks like this. The first one, some hybrid agent allow the user to execute command directly through the Azure agent. And there are another kind of agent that look like this. It doesn't provide the execute command function, but it can kind of like bring in the terminal for a network connection. So you can get access from cloud to on-premises. And then, of course, those agents may have some code deployed on the cloud, but we are not talking about the CI/CD pipeline in this section. And the most interesting thing is they have some synchronization and authentication relationship between Entra ID and your Active Directory or other local devices. Let's talk about the most straightforward execute command through hybrid agent. So Microsoft Intune is an endpoint management solution which you can manage your device such as Windows, Mac OS. It simplifies the app management, meaning you can deploy some third-party application on the cloud to your device. And from the security side, you can automatically deploy some policies, security policies, such as device configuration and compliance to make sure that your device are secure. But for attackers, we didn't care of this. Or we care of deploying our own malicious application or execute scripts on endpoint device. And the request was like we just mentioned, it has to be Windows 10 or 11, and it has to be Entra ID or hybrid joined. And you need to have the Microsoft Intune plan, means you have to pay for this. So then you can execute the command through Microsoft Intune. So the require and role are listed here. Something worth mentioning is that you can grant some service principal with Microsoft Graph Permission device management configuration rewrite, which will give the service principal the permission to execute command on your local device. Action. Cheers. Let's talk about detection. Yeah. So from the cloud side, in the Intune admin center, of course, you can see the script itself. But normally, it could be removed by attackers. So you can only rely on the audit logs. But the audit log, you can see the type of activity such as delete, create, and patch. But when you look into it, it looks like this. You can see who initiated this script, but you can't see the script content itself, which means you don't know what exactly is executing in your local device. So you rely on more host forcing technique again to know what's happening in your endpoint device. And Azure Arc. Azure Arc is very similar to Intune. It's also a cloud management solution, supports Windows, Windows Server, and Ubuntu and other Linux version. It extends the management of Azure to on-premises and multi-cloud and other edge environments, which means it focuses on managing and governing your infrastructure. However, Intune focuses on the device and application management. So what Azure Walk wants you to do is you can manage all your infrastructure just like managing your Azure VM. And so just like your Azure VM, you can configure, you can execute command through the Azure VM extension. You can, when a device deploy Azure Arc, you can also deploy your script through Azure VM extension. And the required role was this here. So we execute the command, who am I? And it turns out we are executing our command with the system privilege, which was great. The detection, of course, again, you can see it in the admin center of the extension, but it could be uninstalled from the attacker. And when you look into the audit log, the same thing happened, is that you can see the type of the activity, but when you look into it, it's still lack of details. So you still need to rely on the host forcing for further investigation. And this is a comprehension of Microsoft Intune and Microsoft Arc compression. Yeah. So likewise, you can also execute command with system privilege, and however, the log details are also both lack of script contents. So general mitigation for that is don't deploy your hybrid agent on your on-premises tier 0 assets. Your cloud assets, tier 0 assets, maybe your global admin account. Of course, they have the permission to control their whole tenant. This is what tier 0 means, and controlling the hybrid agent. However, if your tier 0 agent has deployed a hybrid agent, then once your cloud has been compromised, the attacker will have the ability to control your whole domain on-premise. And let's talk about another attack, network connection. So there's a thing called hybrid connection. It exposes service running in your corporate network to Azure resources. And it works like a VPN, but you don't need to punch a hole on your firewall. So the agent initiates an outbound connection to create a bidirectional socket. And you can use it as a standalone service, but it often works as a feature of app service and function app. And you need all this to be set up. You need an app service or function app is attached to a hybrid connection, and you need to have the permission to have the right permission to write the function app or the app service. So OneNet Lab actually shared with us a very technical environment experience. So it works like this. When the attacker has the right permission to a function app, and it found out it attached to a hybrid connection, and it found out the hybrid connection was connected to a Windows server in the corporate network. So most of the time, the function app will store the local credential in the key vault, which is the best practice. But when you have the right permission, it doesn't matter. Attacker will read it and use that local credential to execute command on the Windows server. Then if the local server is misconfigured, it could also be a local admin account on other devices, such as Entra ID Connect server, which means that the attacker can obtain to control both on-premises and Azure. Another thing is application proxy. It's similar to hybrid connection, but it provides a secure remote access to on-premises web application. And it's used for users that users can access on-premises application through an external URL. And of course, it supports the Azure's authentication control. So unlike hybrid connection, application proxy is used for users. However, it has a higher prerequisite. It relies on the web application that have some kind of critical vulnerability, so that attacker may have the capability to attack this on-premises service. And general detection and mitigation for this attack. Detection, look into your event log, but it really depends on what service you use. Mitigation, deploy all the connection agent in your DMZ to make sure the attacker can lateral movement to other places. The most interesting one, abusing synchronization and authentication. When we look into it, it actually looks like this. So sometimes we know that Active Directory and our device syncs into Entra ID. But most of the time, they were hashes and user can access them directly. But somehow we can obtain the localhost admin password in Entra ID. And when some feature is enabled, we can even reset the domain user's password on Active Directory, which is interesting. And another issue is, of course, Entra ID join have to authenticate with Entra ID to log in. And Active Directory device sometimes have to authenticate to Entra ID, which is another security issue. And let's talk about obtain local admin password first. So it's LAPS, yeah. So everyone is familiar with LAPS. It's a solution to manage your local administrator account on your domain joined computer to protect you against like anti-arm relay or cache credential dump. And Windows LAP, which was released last year, give us another option that you can not only store your local admin account on your Active Directory, but you can also store it on the Entra ID if you are an Entra ID join or hybrid join device. So you can obtain a password just like the picture shows. And most of the time, LAPS is deployed by Intune, and it could be more easily comparing to deploy it manually. So for detection, this is very straightforward. Just look into the audit log. You will see who wants to recover the local admin's password. Synchronization and authentication. The second is reset domain user password, which will be pretty weird because we know that sync account syncs the user's information from Active Directory to Entra ID. So how can we reset the domain user password in Active Directory? It turns out you have to initiate something called a password write-back. And the password write-back can be used to sync password change in Entra ID and write it back to your on-premises AD. And the prerequisite of it is it needs Microsoft Entra ID P1 license, and the AD environment must be set up. And you need to obtain the role to get a role to reset passwords, which will be pretty complicated. But we don't need to understand the details. All 6 of these privileged roles have the ability to reset password of other users. So the attack scenario will look like this. We target an AD privileged user that are synced to Entra ID, which is obviously a misconfiguration. And we reset the AD privileged user's sync account password, then it will be right back to its Active Directory. Then we can log on as the AD privileged user in on-premises, and we found out that we actually log on with the administrator privileges. How to detect it? We can just see the audit log, and it's quite straightforward. So we can find out the object ID is the user that executes the reset password, but however, the IP address is owned by Microsoft, which is not really the IP address owned by the attackers. Again, we'll always see two circles on it. Secure synchronization Satan. For your on-premise accounts, privileged accounts should be set for on-premises only accounts. If you assign a high privilege to sync account, then you may be vulnerable to the password robber attack. So let's talk about Entra ID join device to authenticate to Entra ID. So something is different between Entra ID join and hybrid join. Is that when you're trying to device registration and Entra ID join device, some identity are added to the local admin group. First one is global administrator and Microsoft Entra join device local administrator and a user performing the Microsoft Entra join. So you can see the setting here. And when you log into the device, you can find out that through user, Azure AD device, you can see the username is Echo, and you see some odd SID here, which can be converted to the object ID of global administrator and Microsoft Entra join device local administrator. And here's a very cool function, full feature that is called manage additional local administrator on own Microsoft Entra join device. So as a researcher, of course, I look into it. I think maybe there's some exploit or vulnerability that I can abuse. So I try to know how it works, and I see the document, and this option requires a Microsoft Entra ID P1 or P2 license. So I pay for the license, and I open up my browser and observe how it works. And it actually just assigned a user with Microsoft Entra join devices local administrator role. So I think it's something wrong. Assign a user to a role should be a feature that is free. So yeah, so the Microsoft document is out of date, or you can say that the document is wrong. So Microsoft, return my money. Yeah. So if we try to add ourselves into the Microsoft Entra join device local administrator, it will look like this. We found ourselves successfully logged into the device and found out we are in a group with a weird SID, which maps to the administrator group. That SID can be converted into the object ID of the Entra ID join local device administrator. And through a group nested relationship, we found out ourselves also as a local administrator group. So the attack scenario looks like this. The attacker gets access to one device, maybe through hybrid connection or other methods. And we found out that most Entra ID join devices are in the same intranet. So once the attacker have the required roles, such as a global admin or the Microsoft Entra join device local administrator, you could use that single credential to log into other Entra ID join devices. And let's talk about the last one, Active Directory authentication to Entra ID. So anyone know the difference between login to a password or login with a PIN? What's the technical difference between them for a Windows 11 device? If you log in with your PIN, then this means you are using something called Windows Hello for Business. Windows Hello is a way to sign using your face or fingerprint. So briefly, it's a password authentication provided by Microsoft. And something called Windows Hello for Business provides an enterprise-grade security management capability. It means device attestation, and user can authenticate to Microsoft Entra ID and Active Directory. And of course, you can set up some conditional access policy. And when you use Windows Hello for Business, by default, you are using something called Cloud Kerberos Trust. And hybrid joined, which means when you log into your computer, then you can single sign on to both your on-premises resource and Entra ID resource. So you just need to type in one time, and you can just single sign on to all resources you can get access to. So it works like this. A user tries to log into its workstation through a FIDO key, and however, Entra ID and Active Directory rely on different authentication methods. Entra ID rely on OAuth token, and your Active Directory rely on Kerberos authentication. So, however, your Active Directory obviously don't know what's a FIDO key. So, it rely on the Entra ID for authentication. And however, we need to single sign on to our on-premise AD too. So the Entra ID will return something called a partial TGT, and then the workstation can return it for a full TGT, then complete the Kerberos authentication. So it works like this. By default, you use password hash synchronization to sync the user information to the cloud. So it works like this. And once the user tries to log in with its FIDO key, Entra ID will verify the authentication and then returns with primary flash token, and something we mentioned before is the partial TGT. And then the client will send the partial TGT to the Active Directory and return for the full TGT to complete the Kerberos authentication. So from an attacker aspect, if we control the whole tenant on cloud, we will try to dump the Kerberos server on Entra ID, which is impossible because that virtual Kerberos server was managed by Microsoft. Even you are a global admin, you can't get access to it. So another way is we can manipulate the Entra ID user info, and when we authenticate with a low privileged user, we want to obtain something that returns the high privilege partial TGT. So is it possible? So when we look into how syncing between on-premises and cloud, it relies on something called a source anchor. It maps the object SID and the on-premise SID and the same account name to map the user between on-premise and cloud. So once you have the ability to manipulate the on-premise SID and on-premise same, that means the return partial TGT will be another user's partial TGT. Something worth mentioning is the partial TGT is called partial TGT because it just contains limited information, just only the SID and the same account name. So how do we violate the Cloud Kerberos trust? It works like this. We just gain a low privilege in our Active Directory. However, we control the whole tenant, so we manipulate the user info and try to obtain a high privilege partial TGT, and then we want to return it to a full TGT. However, the return, the exchange between partial TGT and full TGT have an allow list and deny list. The allow list contains all domain user, which is good. However, the deny list contains has the highest priority that contains domain admin and schema admin, all the high privilege groups in the domain. So what's missing? We're seeking for an account with high privilege, but not in the privilege groups. And so we can abuse the account start with MSOL, which execute the password hash synchronization by default. So we need all these prerequisites to be met, and we can execute this attack. So it turns out we can not only get the full TGT, we can also get the NTLM hash of the user. Since that for local servers that do not support Kerberos, you can get the full TGT that contains something with a long-term secret. And the long-term secret turned out to be the user's NTLM hash, which will increase the lifetime of credential. And detection and mitigation. For bad news, we can't see that the SID property has been manipulated. We only see the sync time wasn't in the period. However, we can see that the sync account has been executed by some weird person, not the normal one. The account start with syncs. So the mitigation is to shrink allow this from domain user to only sync account. And there's a comparison of all the attack I mentioned with Entra ID. You can just take a picture of it. Finally, we got some takeaway for you guys. So past imperfection, Windows is not secure. We want to migrate to Azure security. And after Midnight Blizzard, we found out that Azure is not secure too. And so what this session we want to tell you is that both insecure platforms all connect to each other. So for red teamer, my takeaway was, if you are desperately finding new attack paths, look up into the cloud, you will find out a whole new world, and maybe you will have the chance to attack from cloud back to on-premise. And there's some takeaway for also blue teamers, collect your Azure log, your endpoint security still matters even if you migrate to cloud. And the last one, the most important principle is your tier 0 asset should be isolated, both on-premise and cloud. So this is all for my presentation, and thank you all.